Okay, due to popular demand and request, more than anything else, my love of this craft I've been doing for the past 24 years, we're now on part 2 of the 3-way head test. It's been about 2 to 3 weeks since I did the first part, and a lot of reason we've had some trouble down here in Tennessee as far as winds, tornadoes, and some other things, but trying to decide the correct format so that people who've not seen this before would understand it has been the most challenging task. I have wrote a script and went back and forth, and I could do this 1,000 different ways, and I really hope my loyal subscribers, the ones who subscribe to me and the people who've sent me all the emails, thank you very much for it. If it wasn't for y'all's encouragement, believe me when I tell you I wouldn't be doing this, because it's editing the film and I'm learning a lot there, and it's got quite a learning curve to it. The time involved, I sure don't make no money doing this, but at the same time I'm meeting a lot of interesting people who sending me some work, so I want to do my best to show you an understanding several things. But if there's one thing that comes out of this that is clear, if you go into a cylinder head shop that claims to do port work and they have not got one of these, then what you need to do is turn around and walk out the door. It's just that simple. The 3 things, which the purpose of this is to educate y'all so that you know when you go to one of these shops who are the crooks and who are not. That was the purpose of me doing this when I set out to do this, was to, I'm 52, God knows not what's in store for us tomorrow. And I remember some of the things I went through as a young man trying to get a set of ported heads done, which the person I took mine to, he really took me. What he did was he made it shiny and pretty, but it wasn't perform. And maybe it might have performed a little bit better, maybe psychologically in my head, but it sure didn't go a whole lot faster. And without a benchmark like ET or quarter mile elapsed time to really nail it, it's hard to tell what they did unless you get a major improvement, which you can feel by seat of the pants. So there's 3 things that you ask before we start this. I wanted to cover this. There's 3 things you ask when you go to any cylinder head shop that claims to be a porting shop or a cylinder head specialty shop. Number 1, what tool do you have to check the thicknesses of the head? Do you have a sonic checker? You ask to see it. Preferably, the good one is BHJ products. They've been around for a while. This is their top of the line unit, and it goes for around $3,700 retail with the sonic wand for the head, and then another $200 or $300 for the one for the blocks. I have them both because I do a lot of block sonic checking for my customers too. Question number 2. For the money that I pay, how many cc's are you going to increase the volume of the port? And that is really one of the things that maybe in one of the next parts, there's probably going to be as many as 5 or 6 parts of this video before it's done. But the thing is, in other words, if you're charging me $600 to port the head, how many cc's are you removing for that? Are you removing 2? Are you removing 5? Are you removing 10? That way you can get specific. And you can go to Harbor Freight and buy a vernier caliper and a set of snap gauges for about $30. I'm going to show you the positions that you check, which anybody can easily do, and write down these numbers. And I'm going to research right now and I'm trying to find a cheap CC barrette deal where any person can go in there and just measure their ports before they carry it to the shop, because that's where you get these rip-off jerks that polish and shine. Because I'm going to teach you the amount of cc's that is removed, the amount of time it takes to do it, so you're going to know A, if you got your money's worth, and B, if they've given you something that's going to help the performance of the head. the number three question is, when you're talking to the guy that's doing the cylinder heads, you need to find out where he is mathematically. Cylinder head science is not all about the flow bench, although that is 1/3 of the tools used. A lot of it is math. So I'm going to give you some basic questions to ask. I'm going to post these on my website on this section, which under www.headbites.com, in the tab that says Tech Blogs, which is where the story is being written on the three-way test, I'm going to capsize and write an article on things to ask your cylinder head shop when you drop off a pair of heads. And there'll be some math questions which you could ask simply, what is Z factor? What is coefficient discharge? What kind of CFM per cc's removed? There's just a few things you can throw at this guy, and if he can't answer them quickly right off the top of his head and give you some numbers that make sense, you turn around and walk out the door. Do not let them talk with you and hand you this old mess about, oh, I've been doing this for the past 20 or 30 years, blah, blah, blah. Just because, and I'm in this too, because somebody's been doing it 24 years don't mean they've been doing it right. So anyway, on to the sonic checking. What we have is our BHJ sonic checker. You notice my clipboard, which we're going to draw the math on. Then we got the head. Now on the head, we're going to start this. This hour session here is going to be about the ProComp 190cc cylinder head. I chose it first. I got a good friend that sent these from Michigan, Tim Bennett, and I talked with him on this project going on 2 months now from the time he first sent the head. And this is a working project. He's actually coming down from Michigan to pick the heads up. He's going to stay a few days with us, and I'm going to show him Music City. The car isn't nowhere near ready, and he wanted this to be a part of the test. So I wanted to say thank you, Tim. I appreciate your time frame and loaning this to me to do the project and explain to this with the customers. But this 190 head is very interesting, as we already found out one thing that knocked me out of the water. That I don't know if this is how on all of them it is, but the 210cc head I did a year or 2 years ago, it had a 200 thousandths raised runner, and it appears that the 190 head does not. Okay, looking at the port, there's subtle differences, but nothing majorly different. And one thing I would like to say, and I really hate to say this, but in all honesty, y'all wanted to hear it, I have tried to call ProComp 7 times during the past week. I have sent them no less than 6 emails. I cannot get one return call. I cannot get one email from this company. So right now off the bat, if I had to say what kind of tech support or communication, ProComp, you are about the worst damn company I've dealt with in a long time at calling back your customers, returning calls. And I don't understand this, because 2 years ago, Boulder at ProComp, which was the man I dealt with back then, he was more than friendly, talked to me, shot me right up the line, got the information from the people doing the port work on some of the hard questions I had about their head when I was doing a stage 5 for a customer. So I don't know what's happened in the past 2 years, but ProComp Electronics, you need to get your head together and talk to people when they come on the phone and not send them to a dab-blame answering machine. All right, now I got that out of the way. What we're going to do is I'm going to show you one of the things that I hear all the time is the China heads are bad. They have leaky water, or they're bad castings and they leak. We're fixing a sonic check the bowl, all this area right in here in the short turn, then we're going to turn it on the other side and check some other areas up in the port. So we're going to be able to look at where in the port the thicknesses is, so we know where we can remove material, and I'm going to comment along the way about other problems that I see in the head. Now, first, let's go to the sonic checker, which is right here. All right, that sonic checker is right next to this tablet and these 4 plates. Now the reason I got these 4 little plates is these are halves cut off of a cylinder. And if you'll notice, they're stepped. There's a thickness on one side, a thickness on the other. These are calibration discs. Each one of BHJ Sonic checkers comes with 4 of these. And there, so you can check a high side and a low side. Well, why is there 4? Because different companies have different cylinder materials. One's Chrysler, one is GM and Chevy, one is Ford, and one is some of the older stuff, maybe like Studebaker or some of the other ones. I've got the numbers, and they have a code designated on the top. For the purposes of this video, this is an aluminum head. What I have found is the LX casting piece, which is this one, has the closest similarity to being to aluminum within about 2 or 3 thousandths. I've actually cut pieces of aluminum, and I've looked for it everywhere, and I've got a piece here that's a curvature and a double step, but it is, the density of the aluminum is so close. I usually add 10 thousandths to it just to be on the safe side. It would never be off more than that, but I'm going to let you see me calibrate the plate with the sonic wand. And this, of course, is our white lithium, which you have to put it on the wand as you're doing it. So I'm going to go ahead, and the first thing we're going to do is we're going to draw the map. Okay, what I'm going to do, I'm going to turn this around, and we're going to draw the width design, which is width of the head. So we have 2 sheets. We have a L and a W. This one is going to be W. Now, we're first going to start by drawing our circle. This is going to be our bowl. That's going to be the valve guide with the center of the valve guide. Now, the important thing to remember is there's a straight wall side and a push rod side. Since I'm going to start on the end cylinder, which would be the number 7 on this particular head, by looking at the head and the configuration we're going to be looking at, I'm glancing at it right now. This is going to be the straight wall side. This is going to be the push rod side that's got a little bit of a dog leg. Okay? Like I said, my drawing's kind of crude, but I believe I can get the point across. I always draw a hole right here to represent the push rod so that I know where I'm at. Now, we're going to be measuring in spots and depth coming from the top of the valve seat, 300, 600, 900, and 1200, every 300 thousandths. I'll go more into that later why I do that particular thing. But let me get my ruler, and we'll go ahead and start. Okay. I always grab the bottom. The very tippy top is going to be 3. There's 3, 6, 9, 12, and then sometimes I'll get right here, right where the guide is, depending on how tall the bowl is. I can grab a 15. So I go over here on the side, and I'm going to go 3, 6, 9, 12, and 15. Okay? But wait a minute. We got this sliced in 2 or 3 different sections. So what we got to do is go straight off of this and go all the way back to there like that. Because we got this side of the bowl and we got this side of the bowl. Now this is width. We're going to concentrate on this area here and this area here. Okay. So we'll write the same thing. 15, 12, 9, 6, and 3. Okay. So these measurements are going to be showing the thicknesses on this part of the bowl. Now that we got that, let's go on up some. And what we're going to do, I'm going to show you on the part. We're going to go 3, 6. See, we got 3, 6, 9. Notice how 9 is almost in the center of the push rod bulge. Let me see, make sure I get this good for you. That's usually around between 9 and 12 is right around the area. Okay, 15, 18, 21, 24, 27, let's go ahead and write them down, 12, 15, 18, 21, 24, 27, 3, 33. All right, now, it's kind of crude, but right in here is where the short turn radius is. Typically what I drew is I draw a line and dots that's kind of representing the guide. See how the guide is going to come up, and I draw the lines on it. I go on both sides and bring them right up to the dotted lines. So, I think you get the picture. Now we got the dimensions width-wise. We're going to be measuring this right here, right around this area here probably is going to be the dreaded bolt hole. Okay, that's where a head bolt goes through. And then you got this area here that is a built-up material. See, when the air's coming in straight, it has to go around that hump and come back in. This is a major problem on the Siamese port on the small block Chevrolet head. You can refer back to one of my tapes says installing the tubes. This is the area. This is why I'm doing it. This air's coming in there. Boom, it hits, has to go around there and come back. And remember, the single most important thing of the cylinder head porting, air does not like change. If you had to sum up the entire porting concept of a cylinder head, it would be air does not like change. In a nutshell. Okay, so now that we know we can write this down, we can spec this out, we're going to go up here at the top and we're going to call this Sonic Map. I've already got ProComp up there, and then W, which is width. Alright, so let's see how we can relate this chart to the heads. And the hardest thing for me to do is to try to get the sonic checker in view where you can see the port. That's going to be the tricky one for me, so that you can see it, so that it don't look like I'm changing camera angles. And it's just the honesty, transparency is the key to my business. It's the key to everything I do. Not showing you the actual sonic checker, throwing the numbers while I've got that thing on there is I mean, although I'm telling you, and if you was here, you would see I'm not doing it, by the camera not being able to focus on both of them at the same time could leave a doubt that I could be manipulating, that I could be hiding the sonic checker and then editing the film. But by putting it, the whole picture with the head and the sonic checker on there, writing the numbers as I go, there's not a question in the doubt that I'm fooling y'all in any way. All right. This is my checking plate, and on this number, BHJ says 76 thousandths on the thin part, which you can see there's a small shelf and a thick one, 76 and 143. So what I have to do is I just to make sure, I took my Mitutoyo gauge and I catch the very end of it, And then I catch the very end over here on the small side and verify the numbers. I don't know if you can see that. Oh, 76, 76. The top is 142, 143. So I just wanted to show you I'm verifying the piece of metal. Now I take the sonic checker, and what you have to do here, well, I'm trying to make sure I'm seeing. Okay, if I stay up in here. All right, I'm going to take this. I dip it in the white lithium, and I'm going to come over here and I'm going to put it right smack on the piece. Alright, see what the sonic checker's telling me? Now I've got to go to the high side calibration and pull it up. I'm going to stop, take another dip. Alright, now, I'm going to come over here to the high side, 141, 142. Now see, it's real off that way. So I got to pull it down. See how she's jumping? You got to do this 2 or 3 times on it and hit it to make it come out right. I'm going to go ahead and instead of using all my tape, when I get it calibrated, come back and show you the number. Alright, I got it set. Sometimes it takes a while to do this when you haven't calibrated it. You see the numbers, 76 and 143. Now watch the sonic checker. Go to the bottom. A lot of it is finger pressure each time that you put on it. 75, 76, there you go. So the bottom's calibrated. Now we're looking for 143, 144. And keep in mind, it's just, they're going to go back and forth. You're just trying to get it relatively close. See how she's sticking around 142, 143, 144. That's it. So now we know the sonic checker is calibrated on both sides. If you could zoom in, I don't know if I can get you this shot, but what you're looking at here on the wand, it's a funny little piece. I'm going to see if I can zoom you in so you can get a better bird's eye view of it. The end of it is it's split in half, if you will. This side over here sends and this one receives, or it's the other way. Anyway, there's a piece of metal that goes right up the center. One side receives, sends the sound, the other side picks it up, and this is what tells you your thickness. When you're calibrating a high and a low side, like it says, low calibration, high calibration, what you're calibrating is these plates. Like I said, that there's a low side and a high side. of thickness. So we know our sonic checker's ready. Let's do some sonic checking. Okay, as you can see on these lines, the 300 line is right where the seat is, so there's hardly any black. That's your steel seat. Usually the hardened ductile iron seats or stellite seats that they put in aluminum heads are pretty thick, around almost 300 to half-inch thick. So 300 line is going to be hard to judge, but the area between the 3 and the 6, there's the 6, the 9, the 12, and the 15. Now notice how thick the lines are. When I'm sonic checking, I'll make the lines a little bit thicker because I'll be wiping grease, the white lithium, in and out. And if I make them real thin, it gets hard to see. So on the sonicking, I'll leave them thick. Now, usually I need a little bit of time for them to dry, but like I said, this ain't no big deal on the sonicking because I know where I'm going. But what I'm going to try to do now is I'm going to try to adjust the sonic checker where you can see the sonic checker and the numbers, which, golly, this is going to be a challenge, but I think I can do it. Okay, let's see what I can rig up for you. Alright, golly, this is difficult. I need a octopus hands to be able to do this. I think I'm going to go back to that Spider-Man movie and see if old Doc Ock can help me out. Okay, now I'm going to go in here and try to pick off of the 3, which that's right there where that seat is. That's going to be hard to pick up and hit. Yeah, it ain't going to pick up off the 300. I'm going to have to go to the 6, and I'm going to have to somehow, I just can't, I got to be so square in it. Let me see if we can, okay. You can't get as good a shot at the bow, but you can see my hands touching the sonic wand. Wow. 100. Now this is where you got to finagle it right here. You got to take this, I got to keep dipping and go in and out of that area. Now it doesn't surprise me that the bowl is real thin here in this area. This is an area you're not going to do a lot of digging on, but that's a lot thinner than what I expected. What'll happen is it'll start slowing down. I'm moving it as I'm doing it. You can see my finger. Wow. I went from 180. Once I start coming around the side of the bowl, yeah, I'll believe them numbers. Now that is around 600 down in the port, but that's more on this side of the bowl. You see right here, you should be able to see my finger. I'm down here, which would be on this area. As soon as I start to move it up in here, watch what happens. Okay, I've got 100 thousandths is what I'm going to write down on my measurement. Now to transfer the measurement, let's go over here to the paper. Okay, now the area that I'm going to write this in, I was coming up between 3 and 6, so I'm going to write it, since that 3 I couldn't pick, I'm going to write it on the 6, and I'm going to write it at 0.100. Okay, now that's right in this area right here where the bowl is. That's 600 thousandths down. Now let's go back and go to the 9 and 12. Alright. Now we're going for the 9 to 12. See what's happening? And that makes logical sense. 123, 125. All right, so we're going to go 125. I'll go over here and write it on the map. All right, now let's go on down in the bowl. And let's pick up on the 1200 mark, right where the pillar is. I'm going to explain about that pillar. All right, 155 is what I'm going to call that. Okay. All right, now we'll go for the deepest part of the bowl, which is going to be the 15, which really it's going to be hard to do. I can hardly get my sonic wand in there. Yeah, that's a problem because of the guide. I should have went ahead and cut the damn guide out. See, she's thickening up now. That's where the meat's starting to connect. So I'm looking at 185 thousandths. All right. Okay, look what's happening here. As on this part of the bowl, like I said, there's not much meat going to be taken out there because for some reason, I don't know why ProComp did this, right where the seat is on the ProComp, there's a dip. I'd say about a 30 thousandths dip right where the seat is. Then the meat comes back up. Now, I could solve this problem by going in there and putting a bigger valve in it, and that would give me a more clean shot without the dip, but you can't put a bigger valve in this head. I can't say that for sure, but looking at the seats, I'd say pushing it to a 205 would be a stretcher. Anyway, as you can see, looking at our thinnest part, 100, as I move downward toward the bowl, is thickening, 125, and as it gets on down toward the guide, 155, finally 185. Now there's where the beginning, somewhere in here is the beginning of that pillar. And this is disregard, that whole, this is going to be where the bolt hole is. I should have looked at that a little bit better, but disregard that, that's incorrect. This is our pillar, where the center bolt hole is, where I'm going to be modifying and putting the tube. Anyway, those are our thicknesses right there. Now let's go to the other side and see what we got.